Hello everyone, welcome back to this video tutorial on numerical integration in MATLAB using Simpson's third rule. This is the formula we are going to use to develop a program or a function to solve the numerical integrations using Simpson's third rule. So the formula is like that: definite integral from a to b of function f of x is equal to 3 into h by 8 into y0 plus yn plus 3 into y1 plus y2 plus y4, all the remaining terms, plus 2 into all the terms multipliers of 3, that is y3, y6, y9, y12, like that. So the learning outcome of this video: after this video you will be able to create user defined functions to solve numerical integration using Simpson's third rule. We are going to solve these problems in this video tutorial. We will find out the numerical integration for 2x plus 3 and sin x with this a and b values. Okay, so let's move to the MATLAB. So we'll start with the new live script. And I will write some instructions here first of all. So this is using Simpsons create rule in. Okay, now what are the inputs for this video, or sorry, inputs for this function? One dot f of x, the function for which integration has to be done. Okay, then we have a and b values. The limits are the limits of the integration. Then we have n, the number of subdivisions, subintervals. Okay, so next thing is output, and now output will get integration. Numerical, I will write numerical integration. Okay, so this is going to be a fun. We'll start writing the code here. Okay, I'll hide this command window, and as you know that we start with the function keyword. I want integration, and name of this function will be Simpsons underscore 3 underscore 8 underscore rule. Okay, and as usual we have inputs a comma f comma a comma b comma n. Okay, now the next thing is that we'll calculate h. So h is nothing but b minus a by n. We'll suppress this output, then initiate the sum variable. Okay, so sum is equal to, now we have to write the formula first of all here. So we'll understand the formula first, then we'll start writing the code. So equation we have to write, and definite integral of a to b of f of x dx is equal to, we want to add fraction 3h by 8 into, then we have to add some brackets, then this index term y, and I'll copy this thing, and then this will become 0, sorry, here this will become 0, okay. Then there's a yn, okay, plus, now I'll just go to the slides to check the formula. So this, we'll write these terms first, 2 into y3 y6 y9 like this. So 2, and I'll add bracket parenthesis, so y3, this is going to be 3 plus, I want y6 plus y9, and this goes on, then plus the multiplier is 2 here, okay, and then we have 3 into the remaining terms. Let me check once again, 3 into remaining terms, that's correct. So I'll just copy paste this, paste it here, and I'll change this indices. This will be 1, this will be 2, this will be 4. Am I correct? Let's check it once again. 1 2 4, yes, correct. So this is going to be the formula what we are going to use for this. And next thing is h is equal to b minus a by n. Okay, so this is the formula for Simpson's 3/8 rule to find out the numerical integration of f of x. Now the sum is nothing but, we'll start with first y0 and yn. So y0 is nothing but, we have to substitute in f in place of x a. This becomes y0 as usual, we have seen in last 2 videos. Then we'll copy this and we'll paste it here to make yn. If we'll substitute b here, I'll suppress this output. Okay, so till this is okay, as similar to the previous videos only. Then I is going to be a 1 is to n minus 1. Okay, and xi is to be here a plus I into h. So this xi will change, this will become a plus h for x1, a plus 2h for x2, a plus 3h for x3, and it goes on up to xn minus 1. Now we have to write if. So if mod of I comma 3 is equal to 0, this means that I is multiple of 3. I is multiple of 3. We have to write sum is equal to sum plus 2 into subs, substitute in f in place of x, xi. So for mod I3, that is if we divide I with respect to t and 3, and if modulus is 0, that is remainder is 0, this means that this I is the multiple of 3, and in those cases we have to multiply 2 with respect to with y3, y6 and y9. So this is what we have done here, and else we are going to sum is equal to sum plus 3 star subs f comma x comma xi. Okay, then end. So we are going to end this for loop as well. Now we have to calculate the integration, numerical integration. Okay, now this is going to be I is equal to 3 into h into sum divided by 3 into h into sum divided by 8. Okay, and I will write VPA here to get the approximate values in case of trigonometric functions. Okay, and this is going to be an end of this function. Now the next part is to save this function. We'll go to live editor and we'll save this function. Again I have forgot to initiate this star, initiate the symbolic variable x. Let me change syms sims x. So let me check once again. Numerical integration, Simpsons 3/8 rule. These are the inputs, this is the output we are going to get. I is the numerical integration. I'll write it here like this. This is the formula, then function Simpsons 3/8 rule, calculate h, then initiate symbolic variable, then it's going to be a sum, then this for loop, and calculate the numerical integration. That's correct. Now I'll save this Simpsons 3/8 rule. Okay, now the next thing is we have to call this in the settings here. Now first of all we'll write syms, and you have to initiate this x. Now 2 star x plus 3, and then a is going to be 0, b is going to be 10, and n is going to be 10 iterations. Okay, so this is what we are going to be. This is function f of x. This is lower limit of the integration. It's a higher limit of integration. And yes, n is number of the sub intervals. Okay, so this is going to be a initial conditions f and all these things, and we'll run this to check the value. Now here we have not got this the exact value what we want here. So the value is 130. Okay, now what we will do in the next time, we'll increase the number of iterations to hundreds and we'll run this. So this is approaching towards the actual solution. Now I'll change this thing to 500 and I'll run this thing. So you can see here, this is changing. Yeah, so this is the maximum what we will get. Okay, then we'll do this thing for sin x as well, sin of x, and this is going to be a pi. Okay, then we'll start with the 10. Now you can see here we got this 1.98, and if we increase this to 100, we'll go closer but will not get the exact value. Let me check, is there anything at what I can change. 2 into mod 3, if it is 0, this is going to be 3, or the remaining terms. That's correct. No, 3 into h into sum by 8, that's correct. 3 into h, this is going to be 8. So everything is correct, no need to change this thing. We'll change to 1000 and we'll run it once again. So you can see here we are approaching towards the exact solution. So thanks for watching this video. That's it in this video. We are about to end this. Thank you for watching this video. Please like, share and subscribe to the channel. Thank you.